Okay, so this question is kind of thrown in a weird spot in the exam, just based on when I was updating the exam a little bit. Anyways, but let's look at it. This should be a very easy problem. So there's a few ways we can think about this. So x prime is equal to r times x. We want to find the general solution. R is a constant. So you got to think about this. Can I find a function whose derivative is equal to r times itself? Well, let's say r is equal to 1. So let's think about this. If r is equal to 1, now you have to do it for general r, okay? But I'm just kind of walking you through how I would think about this. Okay, if r is equal to 1, you're just wanting a function that's equal to its derivative. Okay, so the choice there is going to be x of t is equal to some constant times e to the t. If I take the derivative, it's equal to itself. If x is equal to c times e to the t, it's equal to itself. Okay, so now I think, well, what happens for a more general value of r? What happens if r isn't equal to 1? How does this change? Well, I mean, you can try multiplying this solution at some point by r. Maybe multiply the c by r or the t by r or whatever, but eventually you realize that the solution is equal to c times e to the rt. Okay, this is like a gimme problem. This is a problem that you can do. This is a problem that a Calc 1 student in principle should be able to do. It doesn't involve any differential equations techniques. But let's say you did want to use some differential equations techniques. So here's some other ways you could do it. Let's say you wanted to treat this as a first order linear equation, which it is. You have x prime minus rx is equal to 0. Okay, this is an integrating factor problem. Mu of t is going to be equal to e to the power of the antiderivative of p, which is minus r in this case. In this case, this is equal to e to the minus rt. Okay, so you multiply both sides of the equation by the integrating factor. The left-hand side is x times e to the minus rt prime. 0 times 0 is equal to 0. You take the antiderivative of both sides. You have x of t e to the minus rt is equal to some constant, or in other words, x of t is equal to some constant times e to the rt. I would not suggest using this method to solve this differential equation. I'm just showing that this is such a fundamental differential equation. There's so many ways of solving it. It should be automatic almost. I mean, really, it just should be automatic. The general solution to x prime equals rx is x of t is equal to c e to the rt. Okay, finally, the other method that I'm going to look at, x prime is equal to rx. Well, this is a separable equation. We've got x prime over x is equal to r. Okay, the left-hand side is equal to the derivative with respect to t of the natural log of the absolute value of x. This is equal to r. We take the antiderivative of both sides. We have the natural log of x is equal to rt plus c. We raise both sides to the power of e. We get x is equal to some constant. Usually we write like e to the c, e to the rt, and then usually we just say e to the c is equal to some other constant, a e to the rt. Okay, so there you go. 3 different methods for solving what should be a very elementary differential equation. This is a gimme type equation. It should be automatic. You should just look at x prime equals rx and know that the general solution is that. Here are 3 ways to think about solving this differential equation.